Have you ever looked at a cantaloupe and thought, gee, I wish I could shrink myself down to the size of a flea and go hiking around on that thing? Well, me neither. But if you did, all you'd have to do is travel about 4.3 billion kilometers to Neptune's largest moon, Triton. No shrink ray required. As far as we know, Triton is the only world in our solar system with what's known as cantaloupe terrain. Parts of its surface have ridges and dents that look almost exactly like a cantaloupe rind. It's a strange little moon in lots of other ways too, so we figured it might be fun to head on over and check it out. Virtually, anyway. Most of what we know about Triton comes from what we can detect with telescopes, plus Voyager 2's flyby in 1989. It's 2,700 kilometers across and has a core made of rock and metal, a mantle just above that made of water ice, and a crust made of frozen nitrogen, which turned out to be important in how the moons changed over time. As we approach the Neptunian system, probably the first thing you'll notice is that Triton's orbit is a little weird. It's circling in the opposite direction from Neptune's rotation. It's the only large moon we know of that does that. Most large moons form from extra rocks and debris left over from when their planets formed, so they end up orbiting in the same direction that the planet spins. Since Triton's going in the opposite direction, some astronomers think it was once part of a system of two worlds orbiting in the distant Kuiper belt. Because if the future moon was out there all on its own, something would have had to slow it down enough to end up in its weird backward orbit. It's much more likely that around 4.5 billion years ago, these paired objects got too close to Neptune, and the planet's gravitational pull captured one of them, which we now know as Triton. The other one was sent flying off into space. In the process, Triton probably destroyed whatever other moons Neptune had at the time, messing up their orbits with its own gravitation. But the weirdness didn't stop there, because then Triton melted. At first, the moon's orbit around Neptune would have been super eccentric, meaning much more like an oval than a circle. Over time, that oval gradually turned into the nearly perfect circular orbit that it has now. But the long time that it spent flying around in giant ellipses, getting close to Neptune and then far away, messed with Triton's insides. The moon experienced tidal heating, where the changing force of gravity made it stretch and unstretch. The friction from all that movement would have produced enough heat to melt most, if not all, of the ice for up to 1 billion years. Which explains why Triton doesn't have many craters. It was mostly liquid for pretty much all of the time that other bodies in the solar system were being bombarded by space rocks. Now, as we get closer to Triton, you'll start to see some more detail on its surface, including that weird-looking cantaloupe terrain. Turns out it's there because of a process known as diapirism, where water ice below the surface pushed up some of the softer nitrogen ice into strange shapes. The moon also has cryovolcanoes, which are like regular volcanoes, except instead of erupting lava, they shoot out nitrogen gas and dust 8 kilometers into the air. And in 2012, a group of astronomers from the University of Maryland proposed something new about Triton. Even though its surface is frozen solid now, its insides might not be. Leftover heat from that ancient tidal friction, plus heat from the decaying radioactive elements in its core, might be enough to melt some of the water ice in the mantle, which means it could have an ocean of liquid water beneath its surface. But whether it does depends on a lot of different factors, like how big the core is, and we just don't have exact numbers on that yet. We might be able to learn more if we send a probe or even a lander to Triton, and plenty of different missions have been proposed over the years. Right now, NASA's funding the development of a mission concept called the Triton Hopper, a rocket-powered rover that would refuel itself with whatever's available on the moon, probably using either ice or the gases in the thin atmosphere. But that project's still in the very earliest stages, so even if it does get the green light, and that's a big if, it'll probably be a few decades before it gets there. We'd better get a move on though, because Triton won't be around forever. Neptune's gravitational pull is slowing down its backward orbit, so Triton is spiraling in toward the planet. And in a little over 1 billion years, it'll reach the point where it either breaks apart and forms a ring around Neptune, or just crashes into it. So if we want to pay a visit in real life, now's the time. Thanks for watching this episode of SciShow Space, and especially to our patrons on Patreon, who help make this show possible. We couldn't do these videos without you. Thanks.